here are solutions to quiz 8 from Math 111. The first question, we're asked to list all possible rational roots of this polynomial. The way to do that is find factors of this number, integer factors, and divide it by integer factors of this coefficient, 1. So really everything's over 1, so it's just plus or minus factors of 50, which are 1, let's see, 2, 3, no, 4, no, 5. Maybe it'd be easier to over here write that 50 is 1 times 50, or 2 times 25, or 5 times 10. That's all of them. So that tells us that our roots are 1, 2, 5, 10, 25, and 50. So here's all the possible rational roots. Now we want to test these until we find one that works. Let's start with the ones. F of 1 is 1 plus 1 minus 15 minus 15 plus 50 plus 50. Does not look like that works. This does not equal 0. However, f of negative 1 would be 1, negative 1. Negative 1 to the 5th is negative 1 plus 1. Minus 15 times minus 1 is plus 15. Minus 15 times positive 1 is minus 15. 50 times negative 1 is negative 50 plus 50. And this does equal 0. So I have that negative 1 is one rational root. And using that, I can now use polynomial long. If I know negative 1 is a root, I know that x plus 1 is a factor. Maybe I'll do this out here. So I know that x plus 1 must divide evenly into x to the 5th plus x to the 4th minus 15x cubed minus 15x squared plus 50x plus 50x plus 50. So if you use polynomial long division, you'll throw an x to the 4th up here because x to the 4th times x is x to the 5th. And if we subtract, get 0 and 0, which is kind of nice. So we'll just bring down the next two terms, negative 15x cubed minus 15x squared. Now we want to put something up here so that when we multiply it times x, we get negative 15x cubed. That something is negative 15x squared. Gives us negative 15x cubed minus 15x squared. And again, get 0 and 0 when we subtract. So we're left with just 50x plus 50. And if you throw a 50 up here on top, what you'll get is 50x plus 50. If you subtract, you get 0. You're happy because that tells you that our polynomial f of x is equal to x plus 1 times x to the 4th minus 15x squared plus 50. Alright, factor f of x to find all roots and their multiplicities. So here's f of x up here. X plus 1 is done, nothing further we can do there, but instead of x to the 4th minus 15x squared plus 50, we could factor that into x squared and x squared. Now we need two numbers that multiply to positive 50 and add to negative 15. See, I think negative 5 and negative 10 will do the trick. So we get to here. From here, I guess you can find all the roots. You could factor one more step if you wanted to, but not into integers. You'll have square root signs in there. So maybe I'll just leave it like this and say, all right, this tells me that I'll switch colors. So from here, I figure out that x plus 1 equals 0. So x equals negative 1, or x squared minus 5 equals 0. So x squared equals 5. So x equals plus or minus the square root of 5. Or finally, x squared minus 10 equals 0. So x squared equals 10. So x equals plus or minus the square root of 10. So what we have for roots, where do I list these? Maybe roots are negative 1, square root of 5, negative square root of 5, square root of 10, and negative square root of 10. and the multiplicity is 1 in each case. 1, 2, 3, 4, 5. Okay, determine the y-intercept. That's the easiest part. You just look up at the linear term here, this 50, because when x equals 0, all these other terms will cancel out. So what we get is that f of 0 equals 50, so y-intercept is 50. Or if you prefer x, 0, comma 50. Either of these are fine. Determine the end behavior. All right, what do we have going on here? We have the leading coefficient is positive and the degree is odd. So leading coefficient is positive, degree is odd. So that tells us that as x goes to infinity, f of x goes to infinity. If you stick in a really large positive number, a really large positive number will come out. And as x goes to negative infinity, f of x also goes to negative infinity. So part G here, sketch an approximate graph of f of x depicting your answers to all this stuff. All right, we can do that. Might not be to scale, but I'll throw something out here. See, the y-intercept was positive 50, so I'll throw a 50 up here. The roots were -1 plus or minus the square root of 5. Let's see, square root of 5 is a little bit more than 2, so maybe right around there feels good. And plus or minus square root of 10, it's a little bit more than 3, so I would say that right around there is close enough. And then what do we have? We have that the end behavior, it's positive on this side and negative on this side. And the multiplicities are all 1, so my graph is going to hit all of these points, all these roots, and go right through them, not bounce off. And then it also has to go through this intercept, so an approximate graph would be something like that. Meant for that to be a little smoother in here, but whatever, close enough. Maybe more like that, although now it looks pretty bad. Let's try again. I don't know if this will be any better. Maybe if I go faster, it won't be as hard to do. Still pretty hard. Drawing on a computer is tough. But something like that. Good enough. And that will end the quiz.